Good day, grade 12s. Welcome to our technical mathematics. Today's lesson is going to be on mensuration. Now, before we can start our lesson for today, I just want to advise the grade 12s, especially those who are doing technical mathematics, that please make sure that you do have an examination guideline. It's a very important document because it explains everything that you need to know before you can go and write your trial exam and the final examination. Every topic that we are doing under technical mathematics is there, and then it outlines the important for each topic that we are doing in technical mathematics, particularly for this topic that we are going to be focusing on today, which is mensuration. All right. And then before waste of time, let us get into business of today. All right, under content, under mensuration, remember this topic, it formed part of what? Paper 2. It's formed part of paper 2. And then under mensuration, a topic that we'll be looking at first is the surface area and the volume. Then we'll be learning on how do we calculate the surface area as well as volume. And then next we have the mid-ordinate rule, where we are going to be calculating area of irregular figures or irregular shapes. Then we'll be using the mid-ordinate rule. So those are two concepts that I want us to focus on for today's lesson. And then if you can just proceed and see what we can. All right, first we are going to start with the area, surface area as well as the volume. Now, for this topic, after we have complete everything, you must be able to calculate a surface area and the volume of right prism, cylinder, pyramid, cones, and sphere, and the combination of this geometric object. So combination I'm referring to, for instance, if you have a cylinder that is combined with what? Maybe with sphere or with a cone, and then you must be able to know that. So it's very important when you have to calculate the surface area as well as the volume, that the formula, which one do you use? For instance, if you want to calculate the surface area of a cylinder, you must be able to know the formula for that. And then number two, you must be able to investigate the effect of volume and surface area when multiplying any dimension by factor k, right? Any dimension of factor k. Then we'll be studying how does this factor k affect the volume and the surface area, right? After multiplying with it. And the last point will be determining the area of an irregular figure using the mid-ordinate rule. Remember, when we talk about irregular figure, we are talking about a figure that is not a rectangle, that is not a square or a triangle, meaning it does not have a specific formula to use to calculate the area. Because now I believe we know, if, for instance, if they ask you to calculate the area of a triangle, we know the formula for that, which is half base times height. All right. Or for instance, rectangle, if you have to calculate the area, is length times breadth. But now when you have an irregular figure, how do we calculate the area? Then today we'll be focusing on that. How do we calculate the area for that irregular figures? Okay, so these are the three important points that you need to know after we have completed this lesson, right? And then let's proceed. Then we'll start with surface area and get example from that. Now, the first question all right, the first question that we need to address on this one, it says the diameter of the sphere is 12 centimeter. Then we are given the diameter of this sphere. Now the first question says, calculate the volume of the sphere, round off the answer to 2 decimal place. Then let's see on how do we calculate the volume of sphere. All right, first remember, for us to be able to calculate sphere, the formula for sphere, it has what? It has radius. Now, in our question or scenario up there, we are being given what? A diameter. Now, hence we have to divide with 2 so that we can get what? A radius. Remember, diameter is half, radius is half of diameter. And then from here, after writing the correct formula for sphere, you then substitute the value of r, which is radius, and it's 6 in this case. Then from there, you take your calculator, and then you just press everything on your calculator, then it's going to give us what? 904.78 centimeter cubed. And my dear learners, it's very important every time when you write, for instance, in this case, we were calculating a volume. So it must be seen with the units there that you are calculating the volume. So you can see the unit is centimeter cube, right? So let us not forget to write the units. And the second question that we have to calculate is what? Is the surface area. Surface of area of the sphere. And let's see on how do we do that. Then you write the formula for surface area, which is 4 pi r squared. Then the next step, you just substitute the value of r, which is 6, and then you just press your calculator, then it's going to give us 152.339 centimeter squared. All right. And even the instruction is very clear that we should write or we should round off the answer to 2 decimal place. And every time when you are given such an instruction, please, it's very important to follow that instructions. All right. Because you might not get a mark if, for instance, if you write a 3 decimal place, whereas to 2 decimal place. I think we have answered the last question. We can now proceed. Let's proceed. All right, we have another question, and then this question says, calculate the volume of a cone with a diameter. You can see there is a diameter down there. Sorry, let me just remove this. All right, of 18 centimeter, and the height of this cone is 24 centimeter, and round off the answer to the nearest whole number. Then let's see on how do we calculate a volume of a cone. First, you write the correct formula for that, which is 1/3 times area of a base times height. Area of a base times height. Now, which is 1/3 pi r squared times height. Now you can see from this question here, we don't have what? We don't have radius, but we have diameter. But earlier on, remember, we explained the issue around diameter and radius. So we're going to be calculating half of 18, which is 9 in this case, we can see, and the height is 24. Then from there, you just press your calculator, and it's going to give you 2036 centimeter cubed. So that's how you should now calculate what? The volume of a cone. The next question, which says calculate the surface area of a cylinder in centimeter squared, meaning after you have calculated the surface area, it must be in a unit of centimeter squared. Now, if the height is 26 centimeter and the radius is 100 millimeter, you can see now we have another unit instead of centimeter is millimeter, and round off your answer to the nearest whole number. Then surely first we have to now convert the radius to centimeter, because now it is given in terms of millimeter. All right, now we have to convert that. Then it's going to give us what? It's going to give us 10. Now remember, when you convert millimeter to centimeter, you're going to divide with 10. When you move from millimeter to centimeter, you divide with 10. All right, then it's going to give us what? 10 centimeter. Now our units now are the same. Then you can just go and calculate the surface area for that cylinder. Then you write the correct formula for that, and then since we've got the value of R, then as well as what the height. Then the next step, you just substitute the values, then you press your calculator, then it's going to give us 2,262 centimeter squared. All right, and then let me remind you again, the units are very important, especially on this topic. You must always remember to write the units, because if you don't write the units, then we will not know that you are calculating surface area. All right, and then I think we have answered everything. Then we can just proceed. We are still under surface area and volume. All right, now we have a scenario, and then let's study this scenario. It says a solid hollowed shape was constructed from a cylindrical rod with a conical section shaded and removed, as shown in the figure below. You can see here's that figure there. The diameter of both cylinder and the cone is 10 centimeter. The diameter, yes, and then the height of the cylinder is now 15 centimeter. The height of the cone is 12 centimeter, and the slant height of the cone is 13 centimeter. I want to believe that you still remember what is the meaning of this slant height of your cone. I can just make example here. For instance, if we have a perpendicular line like this one here, and then we know from this point up there is 12 centimeter, and then the slight height that we are referring to is this side here. Let me just show you with this pen. So this is the slight height that we are referring to, and is 13 in this case. Now, the first question that we have to address on this one, it says calculate the total surface area of the hollowed shape. Now this one hollowed shape is which portion? Let me just show you. Let me just remove this now. Now we can see that we are having two shapes, which is the cylinder. You can see the cylinder there, and then inside the cylinder we've got a cone, right? Now the surface area that we are in need of is this this empty space there. Can you see that empty space? This space which is formed by this a cone. So we'll be calculating that surface area there. Then now let's see on how do we calculate that. Now first we have to calculate what the surface area of a cylinder. Now let's start calculating the surface area of a cylinder. You write the formula there. You can see next to this object we've got formulas. that you can use. And then the next step, you just substitute. Remember, we had a diameter which is 10 centimeter, but now we want a radius, and then of course it's going to be 5, and then the height is what is equals to 15. Then you just press your calculator, then it's going to give us 345, 58 centimeter squared. Then thereafter, then we calculate the area, the surface area of what? Of cone. And then you write the formula for cone. And then the next step, you substitute. Remember this S stands for what? The slant height. And then we have that from our scenario, which is 13 centimeter. And then from there, you press your calculator, then it's going to give us 104.20 centimeter squared. Now, because we want the surface area for this one, the surface area for this shape, which is Hollywood shape, then we are going to say the total surface area of that shape, which is Hollywood shape. Then it's going to say the surface area of a cylinder minus the surface area of cone. Then it's going to give us what? It's going to give us 141.38 centimeters squared. So this is the surface area that will be calculating. All right. I think everything is fine. And then now we can just proceed. The question is still continuing. And let's see on what question are we going to get on that. We are now having another question that says determine whether the volume of Hollywood shape is more than 280 pi centimeter cube. Determine whether the volume of the Hollywood shape is more than 280 pi centimeter cubed. Then let's see on how do we do that. Now, first, we have to calculate the volume of a cylinder, and then you write the correct formula for that. Then the next step, you just substitute your values. R is 5, and then the height is 15, of course. And then from there, you just press your calculator. Then the calculator is going to give us what? 1,178.1 centimeter cubed. Okay. And then the next step, then we are now going to be calculating the volume of a cone. Let's calculate the volume of a cone. Then you just do the correct substitution. And then from there, you press your calculator, then it's going to give us 314.16 centimeter centimeter cubed, right? Now, because we want to calculate the volume of Hollywood shape, which is this empty space there, this space that we want to calculate the volume. So then we are going to say the volume of Hollywood shape is equals to the volume of cylinder minus the volume of what? The volume of cone. Then it's going to give us 863.94 centimeter. But remember, what was the question? The question said we should now determine whether the volume of the Hollywood shape is more than 280 pi centimeter cube. Now, the final conclusion, it will say the volume of the Hollywood is less than this, because if you press your calculator on this one to say 280 pi, that is going to give us 879.65 centimeter cubed. You can see this value is bigger than this one, right? So it tells us that the volume of a Hollywood is less than this value there, or this volume. Okay. I think we are done. We can now proceed. The closed right cylindrical container shown in the diagram below, you can see here is that cylindrical container has been made such that exactly 3 identical spherical metal balls fit tightly inside. The entire height age of the cylinder is now what is 33 centimeter, and the interior diameter of the cylinder is 11 centimeter, and the radius of the metal ball is 5.5 centimeter. And then the first question that we have to answer it is it says calculate the total interior surface area of the closed cylindrical container, meaning we need to calculate the surface area of this cylindrical container. And then let's see on how do we do that. Then we write the correct formula for that. And then remember, we also need the we need the radius for that. What is the radius? Remember from the scenario, I think we have the interior diameter of the cylinder is 11 centimeter. But now we don't want diameter, we need the radius. Then it's going to be 11 divided by 2. Then it's going to give us 5.5. And then now the next step, you just substitute 5.5. And then of course the height, which is 33 centimeter there. Then you press your calculator. Sorry, you just press your calculator, and it's going to give us 1,330.46 centimeter squared. And then the next question, calculate the volume of one spherical metal ball, meaning we need to calculate a volume of one metal ball, right? This spherical one metal ball. Now let's see how do we do that. Remember, it's a sphere, and then now you write the correct formula for that. The next step, you're going to substitute the value of R. Then after, you just press your calculator, then it's going to give us 696.91 centimeter cubed, right? Because now we are calculating the volume. And then third question, it says determine the volume of the empty inside the cylindrical container with 3 metal bonds, meaning they want us to calculate the volume of the volume of this empty space. You can see this space that we are having here. Then we have to calculate that volume of that space. Now, how do we do that? The first, you have to now calculate the volume of the volume of the cylinder, and then you just substitute the values. Then it's going to give us 3,136.09 centimeter cubed. So this is the volume for the whole cylinder or cylindrical container. All right. Thereafter, we have to know the volume of these 3 balls or metal balls, because now from the previous question or the solution, we calculate the volume of only one ball, which is this 696.91. Now, since we want the volume of the whole 3 balls, metal ball, then we are going to say 3 times the volume of 1, then it's going to give us how much? 2090.70 centimeter cubed, right? So this is the volume that is occupied by these metal balls, all right? Now, because we want the volume of this empty space there, then surely we're going to say the volume of empty space inside the cylindrical container, then this is going to be the volume of the whole cylindrical container minus the volume of the 3 metal balls, which is this one. Then you just subtract them. Then the volume which is left is for this space there, and then which is 1045.39 centimeter cube. So that's how you should now calculate the volume of the empty space. Okay, and then we can now proceed. We are still under surface area and volume. Let's see what we're having there. The object below is made up from a cylinder and a hemisphere. The cylinder has a radius of 10 centimeter and a height of 32 centimeter. Now, the first question says, calculate the volume of the object. The volume of the object, meaning we have to calculate the volume of the whole object. A cylinder combined with the hemisphere. You can see this top part there, then we call it hemisphere, that top part. Okay, and then I believe that all of us, we know what is hemisphere. Remember, hemisphere is half of sphere. Remember, when you talk about sphere, we are talking about a shape like a ball. So half of that, then we call it hemisphere. And then now let's now calculate the volume of that particular object. First, we have to calculate the volume of the cylinder. Let's calculate the volume of cylinder. You write the correct formula, and then from there, because now we are having the radius, which is 10 centimeter, you can see we have substituted with 10 there. What is the height? The height is 32. Then just press our calculator there. It's going to give us, I believe this is the correct answer there, which is 10,053 centimeter cubed. I believe that is the correct answer. And then from there, then we calculate the volume of what? Of sphere, because we don't have a specific formula for hemisphere. But since we know that hemisphere is half of sphere, then it's proper to calculate the volume of sphere first, all right? And then which is going to give us this one, which is 4,189 centimeter cubed. Thereafter, since we are in need of volume of hemisphere, then we just divide with 2, then it's going to give us 2,095 centimeter cubed. All right. Now, since we have determined the volume of cylinder and the volume of hemisphere, then we are going to write the total volume of the object. Then we're going to add them together. Then it's going to give us 12,148 centimeter cubed. So that's how you should calculate the volume of the whole object, right? So this is the one example of a combined geometric object where you are having more than one object. In this case, you can see there was a cylinder together with a hemisphere. So we had to calculate the volume for that. The effect on volume and surface area when multiply any dimension by the factor K. The first question, the scenario says a sphere has a radius of 12 centimeter and a radius of sphere is multiplied by the factor of 3. It's going to be multiplied by that thing. And then from there, we're going to compare what's going to happen. Now, the first question says, calculate the volume of the sphere with a radius of 12 centimeter and leave the answer in terms of pi. Leave your answer in terms of pi. Now, first we calculate the volume of sphere, and then from there we then substitute, because we've got the radius, which is 12 centimeter. Then our answer is 2,304 pi. You can see pi there, centimeter cube, right? Now, I've realized something, that majority of learners, they struggle to write their answer in terms of pi. Now, let me just advise you on how do we do that. Now, when you press your calculator, you don't include pi. You just put pi aside, then you just press your calculator and say 4/3 multiply by what? 12 cubed, right? Then it's going to give us 2,304 pi. You don't include that pi, because once you include the pi, then the answer that you're going to get is going to give us a decimal number there, and pi is not going to be there on that answer. All right, and then so this how this is the volume of that sphere. And the next question says, if the radius of the sphere is multiplied by the factor 3, calculate the volume of sphere. Now we are going to multiply the radius of the original radius of the sphere with 3. And then let's see on how do we do that. You can see that this 12 multiplied by the factor 3, then it gives us 36. Now our radius is no longer 12, but is now 36 centimeter. Then let's now calculate the volume again. And then this is the answer. All right, it's 62,208 pi centimeter cubed. Now, number 3, it says, what do you notice about the effect on the volume when multiplying the radius by the factor of 3? What do you notice about that? Now, when you take actually, there was a typing error here. This is it's not supposed to be surface area, but volume, right? This is volume, not surface area, because we are calculating volume, not surface area. So this is V, surface area. Then when you take these two answers, then you divide them together, then they give us what? They give us 27. Then what does it mean? It means that when you multiply the radius by a factor 3, the effect is that the volume is multiplied by the factor of cubed, which is this one. You can see that when you say 3 to the power 3, then it's going to give us 27. So that is the effect of K. Okay. Yeah, I think we are done. Now we can proceed to the next question. Now, we are done with surface area and volume. We are now looking at midpoint ordinary, where we are going to be calculating the area of irregular figures. Now, determine the area of an irregular figure using the mid-ordinate rule. The formula that we are going to use is area equals to a width of interval multiplied by the sum of the mid-ordinates. And then let's get example where I'm going to explain what is the width of interval as well as the mid-ordinates. All right, now the first question says calculate the area of the irregular shape. You can see this irregular shape, right? It's not easy for us to calculate the area of this shape, because if it was a square, then it was very simple to calculate the area of a square, or a triangle or rectangle, right? And then now we should calculate the area of a rectangular shape, irregular shape, using the mid-ordinate rule. And then first, let's see on how do we do that. First, we are going to determine the mid-ordinate, right? The mid-ordinate, how do you obtain that? you are going to take the first ordinate, in this case is 0, plus the second ordinate, in this case is 2,5. Then you divide with 2, then it's going to give us 1,25. Then you do the same with the next. You take the ordinate 2,5 plus 3,5. Then you divide with 2, then it's going to give us 3. Then you go again and you say 3,5 plus 5,0, or you can just say 5, right? And then you divide with 2, then it's going to give us 4,25 meter. And then you proceed and then say 5 or 5,0 plus 4,6 divided by 2, then is equals to 4,8 meter. Then you proceed and say 4,6 plus 3,2 divided by 2, then it's going to give us 3,9 meter. And the last one, which is 3,2 plus 0 there, divided by 2, then we are having 1,6 meter. Then those are mid-ordinate, right? We just determine the mid-ordinates because the formula is very clear that we are going to add all those ordinates. You can see the formula says the sum of all mid-ordinates. Then we've just determined them. Then the next step, you write the formula. And then what is this width of interval? I think that is the distance between the ordinates, which is 10 meter. In this case, you can see it's 10 meter, 10 meter. All right. So that is width of interval. Then you just put the 10 there. Then you add all the ordinates, and then the area is going to be 188 centimeters squared. So that's how you should now calculate the area of an irregular figure. Now let's get another question. Calculate the area of the irregular shape using the mid-ordinate. First, let's determine the ordinate. You take the first ordinate plus the second one, you divide with 2, then it's going to give us 150. And then you do the same with this one, 160 plus 200 divided by 2, which fourth one is 190 plus 180 divided by 2 is equals to 185. And then fifth one is 180 plus 130 divided by 2, it gives us 155. Of course, the last one is 130 plus 0 divided by 2 equals to 65. You can see the last ordinate there is 0. You can see it's 0 there. So it's very important that we should also include it. And then from there, you write the formula. Now, what is the interval? What is the width interval? You can see from this picture is 50, right? The space between the ordinates. Then you just substitute with 50, then you add all the ordinates. Then our area now is going to be 46,500 units squared. So it's very important, once again, that let us try to include the units as well. Now, you can see from this example that we are just calculate, it does not have any unit, but it doesn't mean that we must just leave our answer without writing this unit squared. So if it does not have units, you just write unit squared to show that you were calculating the area, okay? And then let's proceed. We have another example. Let's see. The irregular figure below has a straight side, which is 24 centimeter long. You can see here's 24 centimeter long, which divided into 4 equal parts. The ordinates divide, the parts are 12 centimeter, 9.3 centimeter, 8.5 centimeter, and P. The length of P is half the length of the first ordinate. The first question, write down the value of P. Let us write the value of P. Now, they say the value of P equals to 6 centimeter. That is the value of P. Why? Because it's very clear from this scenario that the length of P is half the length of the first ordinate. What is the first ordinate in this case? You can see is 12. So half of 12 is 6. Then we just determine the value of P. Second question says, hence, determine the area of the irregular figure by the mid-ordinate rule. Let us first determine the mid-ordinate. 12 plus 10,2 divided by 2 is 11,1. And then 10,2 plus 9,3 divided by 2, then it gives us 9,75 centimeter. And then, of course, 9,3 plus 8,5 divided by 2, it gives us 8,9. And the last part is 8,5 plus 6 divided by 2, it gives us 7,25, because we have determined that value of P. And then we agreed that that value of P is 6. Okay, then you write the formula there. Now, the challenge is the width of interval. Is now, they just give us the distance of everything. You can see the distance of this, which is 24 centimeter. But now we want the width interval, meaning the distance between these ordinates, the distance between from this point until this one. We need that distance. But because this is very clear from this now that which is divided by 4 equal parts, you can see these parts are equal. You can see the space between, they are equal. Now, how many parts do we have here? We've got 1, 2, 3, 4. So then we're going to say 24 divided by 4, then it's going to give us how much? And then you can see that's going to give us 6. It's going to give us 6. Let me just remove this. All right. Now the width of interval now is 6 centimeter. All right. All right. Now from there you add all the mid ordinates together, and now the area is going to be 222 centimeters squared. So this is how you should calculate that area. The irregular shape below has one straight side into 4 equal parts, which is 4 meter apart. Then the ordinate divide are 6,2, and then the other one is y 5,1, 4,9, and 2 meter there. You can see there is one ordinate which is unknown, and then in this case just y there. We don't know what is the value for that ordinate. And then let's see. All right, the first question says calculate the value of y using the mid-ordinate rule if the area of the irregular shape is 72 meter squared. Now you can see that in this question we're having the area, so we don't have to calculate the area in this case, but now we'll have to calculate one ordinate, which is y. Then we have to determine that value there. Then let's go and see how do we calculate that. Now first we are going to determine the mid ordinate, then to say 6,2 plus y divided by 2, then it's going to give us 3,1 plus y over 2. All right. And the second one, you say y plus 5,1 divided by 2, then it's going to give us y over 2 plus 2,55. The third is 5,1 plus 4,9 divided by 2, then it's going to give us 5 meter. And then the fourth one is 4,9 plus 2 divided by 2, then it gives us 3,4 meter. I think that is the last mid ordinate. And then from there, you write the formula there. But because remember this one, we are having a area already, then we just substitute the area, which is 72, and then width of interval is 4. And then now you add all the ordinates that we have determined, which is 3,1 plus 2,55 plus 5 plus 3,45, then plus y over 2 plus y over 2. The third step, you can now add this one together, then this is going to give us 14,1. Then when we add this 2, 1 over 2y, 1 over 2y is the same as y. Then the third step, what we're going to do, then you can now divide with what? You can divide with 4 both sides. Then if you divide 4 both sides, then of course this is going to be 72 over 4, then it's going to give us 18. And then on this side, we are left with 14,1 plus y. Because now we are in need of y, then obviously we're going to transpose this 14,1 to the right hand side. And then you say 18 minus 14,1, then it's going to give us 3,9 meter. So this is the answer for that ordinate. So we've just determined the value of y. All right. All right. Thank you very much for being with me on this lesson. It was a very interesting one. I think I will just leave you with this message, my dear learners, that says never give up. Today is harder, tomorrow will be worse, but the day after tomorrow will be sunshine. Now let us make sure that we practice before we write our trial examination or the final examination. And then once again, please try to have what examination guideline for technical mathematics. I have already explained the importance of having that document, and then you can get that document from the DB website, search for it, and then then you go through it, particularly for this topic that we will be focusing on for today's lesson. Thank you very much. Have a nice evening.